So our big topic for the sequence is dilution. Everything that we've been discussing this morning, percentage concentration is the foundation of dilution and alligation. So to define dilution versus alligation, take note of the spelling. Alligation is with an I, okay? Allegation is a law terminology, a legal terminology. You're being accused of allegation. I still see some instructors use this spelling and it bugs me. In math and pharmacy is an I, like an alligator. Okay, this is a terminology. Okay, law terminology. So dilution, if I'm to explain it, I've been drawing a lot today. Coffee. Who likes their coffee strong? I do. Okay, so that's a good example of strength or concentration of a drug or a substance. Okay, so you want your coffee strong. If we are to put a number in that coffee, how strong do you want your coffee in percentage? Those who raise their hands. Daya, how strong do you want your coffee?
Like 75% coffee.
75% coffee. I love dark chocolate. And my friend would spit out that dark chocolate because I can do 90% dark chocolate. Like, what the heck is this? Right? She said, I can do 60, but not 95 or 90. Right? Because it tastes like they're chewing cocoa or coffee grounds for them. Like, okay. Yeah, I think for dark chocolate, 60 is a happy medium. 60, 75. Okay. Michelle, how much percentage? If we're going to put numbers in coffee, how strong do you want your coffee in percentage? 75 sounds good. Okay. Who else raised their hands? Emily, you raised your hand. Strong coffee. Who doesn't drink coffee, by the way? Oh my God. Mr. Jackson doesn't drink coffee too. Okay. Maybe you want to start drinking coffee. I prescribe that for ADHD to my students for focus. I joke about it. I tease Mr. Jackson all the time. I said, can't be friends. I said that, but we played golf together. We can't be friends. You don't drink coffee. Yeah. Okay. So anyway, who else? Strong coffee? Erin, percentage coffee.
I'd probably say 80%. I like espresso.
Oh, 80%. So you said 75%, Daya and Michelle. A pure, what did I say? A purist? 100%. So if it's 75%, it's 75% coffee. And what's the remainder? 25% water. That's a strong coffee still, right? But I'm just explaining to you the concept of dilution right now. Right? Okay, next, 80%. I like espresso, Aaron said. It should have 80% coffee. Okay, and with the what's the water part? 20% water. If we are to put a number or a percentage in our coffee, comparing this to 75 and 80, which one is more diluted? 75. The more diluted means the more water. I ask my students, well, if you accidentally made your coffee strong, what do? And you don't like it that strong. Students would usually answer, add more water. But then every now and then I'll get students to say, add more creamer. I like that answer too. Heat dilutes your coffee too. But if you're talking about dilution, it has something to do with water. Okay? So picture that. Okay? If you see any percentage, that means the other portion is water or a base that has 0%. Okay? A Vaseline is 0% concentration. It's a base that's neutral. It doesn't have concentration. It's a base. You follow me? Okay. So let's continue. Dilution. Dilution is when you add water to make it less strong or less concentrated. Higher the number, the stronger, the more concentrated the solution or the substances. Are you following? So there's only two ingredients, water and the active ingredient. That's dilution. Okay? You're making it, dilution is you're making it from higher to lower. That is important. We don't make it lower to higher. Higher to lower only, one way only. In alligation, there's three strands. Okay? There's a higher concentration substance, and there's a lower concentration substance. And the problem is how much of these higher concentration and how much of this lower concentration do we need to make the middle concentration. Following. This is just the intro. Okay? So how many ingredients are there that are active? 2 active ingredients. How many active ingredients is in dilution? 1, because water is 0. You following?
Dilation.
In dilution, there's only 1 active ingredient because the other one is water, 0%. You following? In alligation, there are 2 active ingredients in different strengths. One is higher, one is lower. And the problem is, how much of this do you need and how much of this do you need to make this middle concentration? It's annoying because it doesn't come in that concentration. Like I said, the big pharma, the big guys know now to make this right away, right? To make this concentration right away, and it's available. But in tests, it still asks you. In practice, you need this dilution part. You're going to have to dilute the IV, the drugs in the vial, in the ampule, before you could inject it to the IV bag or directly to the patient. Is that clear? The 2 terminologies clear? Because I'm going to make an extension of the explanation again. Clear? Okay. Well, Miss L, I watched in your video that you can use alligation method or the tic-tac-toe method, okay, for dilution. Correct. You may. Okay? You may. And how do you do that? By using water and plugging water as 0. And I'm going to park this topic. Say, for example, you want a 70% concentration into a 30% concentration. You got to add water. And in a dilution problem, the question is how much water do you have to add to make it from 70 to 30, right? But in alligation, we use a popular method called the tic-tac-toe method. This is where you put the higher concentration, right? And the lower concentration. And this is the middle concentration. Can I use the tic-tac-toe method or the alligation method to calculate for dilution? Yes. What do? You put the higher concentration, in my example, 70%, and you put water as 0. And what did I say to make? A 30% solution. So yes. Do I like using this method for dilution? No. Because it's longer. I have a formula I use for dilution. But sometimes the test will say using, but you're not going to see this in the board exam because board exam is a multiple choice question. But I've seen some final exams for PIMA that says using the alligation method, calculate this, and it's a dilution problem. So I'm going to park this. It's just an introduction, and I'm going to go back to dilution. And you're going to know why I don't like using tic-tac-toe for dilution, because there is a formula for dilution. Okay, what's the formula Okay? We'll get back to this. What's the formula for dilution? Anyone? It's one of the formulas I know by heart, and I'll never forget. The dilution formula is C1V1 equals C2V2. Easy to remember, right? C1V1 equals C2V2. C1 stands for initial concentration. C2 then stands for final concentration. So what's V1? V1 then is initial volume. So what's V2? Final volume. If you ask a pharmacist what's the formula for dilution, they're going to give this to you. But some technicians, many technicians, changed it. I don't know it by heart, so I'm going to go slow. They call it initial strength times initial volume. This is exactly the reason why I don't like using this abbreviation, because it's IV. Equals final strength times final volume. I'm presenting both to you so that you're not like, oh, what did my pharmacist say? C1V1, because if you ask us, C1V1 equals C2V2. Okay? But you'll hear this more from technicians. Same exact banana. Why? Strength and concentration is the same. One and initial. Right? Okay. Let's put it in a problem. Okay, in an example. My first example a while ago was 70%, right? There's a 70% substance. Okay. You have to make it a 30%. (500 ml) solution. So let's erase this so you're not confused. Okay. The problem is I have a 70% solution drug, okay? And the prescription says you have to dilute it to 30%, 500 ml. If I'm to use the formula C1V1 equals C2V2, what's my initial concentration? 70%. 70%. Right? Do I have an initial volume? The question is, how much of the 70% do I need to make a 30% 500 ml? Do I have an initial volume? So this will be my ml. You following? Okay. To make. So this arrow means to make. That's your final. Your creation is your final. To make, what's my C2? 30%. What's my final volume? 500 ml. Remember, the question here is how much of the 70% do I need to make a diluted solution of 30%? So this will be 30 times 500, correct? Divided by 70. Did you get that? And what's my X? My X should be in ml, correct? Change it to decimal if you want to, or just take out the percent at this point. You would do the take out the percent, then you're going to have to multiply by it. So just, or just change it to decimal. What's the answer?
214.29.
214.29. 29 ml. Who got the same exact answer? Okay. This tells you, look at this, that you need 214.29 ml of the 70% substance or drug or solution to make a 500 ml 30% concentration. Did you get that? Isn't the formula so easy to use? Okay. But some students would say, Miss Anna, I like using the tic-tac-toe for dilution too. We could do that, but we have to talk about dilution first. Okay. Disclaimer, this packet is not made by me. So you can just go through it. If it clicks with you, good. If it doesn't, it is. This is made by an instructor from 10 years ago. Instructor. Okay. So pay attention first and make that your second option. Okay? Pay attention first and make that your second option. That clear? Pay attention to me first. For me to explain alligation better. Okay, now here. So in a final exam or in a board exam, if I see that it's a dilution question, I just use the formula. How do I know it's a dilution question? There's only one strength. So I know that water is the other variable. How do I know that it's an alligation question? If there are two strengths. All the way. How do I know that it's an alligation question? There are two strengths. And the best way to solve that problem is using the tic-tac-toe method. So the problem, I want to leave this here, okay? Because I want to get back to it. How do we solve an alligation problem? Say, for example, the problem is, okay, which was my first example a while ago. There's a substance that's 70% strength, okay? And there's another substance that's 30% strength. And I have to make, was it 40?
Yeah, 40, yeah.
And I have to make a 40% strength, right? 1 liter. I'll add that because you need that. A 1 liter, 40% strength. So the question actually is two. How much of the 70% do I need? And how much of the 30% do I need to make a 40% 1 liter solution? Let's try alligation. Let's do it. Tic-tac-toe method or alligation method. This is how we set it up. Okay. I tweaked how to do this from all the books that I did. Why? Because I realized that the students were having a hard time using fractions. So what I did, I explained it in ratio and proportion. And the students got it. Okay? So you may not find it in any book the way I do it, because I adjusted the way I do alligation based on most students' understanding, comprehension. Is that clear? Okay. So higher concentration is here for the tic-tac-toe method. What's at the bottom? The lower concentration. And the to make is going to be where? In the middle. I'm just doing, you can do it anywhere you want. Those are just numbers that popped in my head. Yeah. Okay. But I'm just explaining to you how alligation works. I will use this method if I see two concentrations. I will use the C1, V1 equals C2, V2 if I saw one concentration in the problem. Clear? Okay. So 70, 30, higher concentration, lower concentration, middle concentration. Usually the two main. Okay, first step, subtract crisscross, absolute only. 70 minus 30 minus 40 is? 30. What I do, this is one of the changes that I did, right? This is one of the changes I did. I put an extra line here, okay? 70 minus 40 is? 30. I put 30 parts, not percent. Absolute value. So there's no plus or minus, okay? And then 30 minus 40 or 40 minus 30 is? 10 parts. What helped students a lot? When I start putting a box right over here, but have an extra space on the side. When I started doing this, it started clicking. And then another box right over here, but put an extra space on the right side. Okay? The next step is to add these two parts together. That's why I put an extra line here. Did you see? It's not just a tic-tac-toe, no, there's an extra line. Yeah? 10 parts plus 30 parts is?
40.
So I put the word 40 parts here. But for me to not be confused, there's a floating number here. I bring this down right over here. 40%. Okay? When I started doing this, the students started understanding because nobody does it this way. Because I'm picking up from where the students are. So make another box right over here. And I'll explain to you what this means. This means that you need 10 parts of the 70%. That's why I made a box or a rectangle, whatever you want to call it. This means that you need 30 parts of that 30%. And because this is a floating number, I want you to understand and it starts clicking that the 40% will be a total of 40 parts. Now, this is when I made the big change. I started using ratio and proportion because that's what clicked with the students. And how do we do that? Well, you can use any of this now, right? And how do we do that? Because we still have to put how much are these equivalent to ml. Are you following? This is your total. Do you have a total? 1 liter. What does that convert to in ml?
1,000.
And isn't this your total? So I will put 1,000 ml right over here. I really don't think you can find this in any book, the way it's done. Okay? But this is what most students, what helped most students. Okay, 1,000 ml. I have a working equation. I can solve this and I can solve this using ratio and proportion, right? I'd start off with, oh, how much is that in terms of ml, right? I can solve using if 40 parts is 1,000 ml. What do you want to solve first?
30.
Which one?
30.
You're going to solve the 30? You're going to solve the 30? Then 30 parts is to X ml. Which means you have to put your answer here, huh? That's why I started doing the box. So, because the common problem through the years, remember I've been teaching 15 years, 14 years here. The common problem I've been seeing is the students solve it, but they put the numbers in the wrong one. The moment I start in the wrong places, the moment I started doing this, they started plugging it at the right places. Okay? So we're on 30. What's the answer?
750.
750 ml. I have to put 750 ml. There are two ways to solve the 70%. I can either continue with ratio and proportion, right? If 40 parts is 1,000 ml, 10 parts is 2 xml. Or simply
Subtract.
the total is 1,000, you got 750. So what's the remainder?
150 ml.
250 ml. Did you see that? Which means you need 250 ml of this. And you need how much?
750 ml.
750 ml of this to make 40%, 1,000 ml. So you're going to pour that in a graduated cylinder. 250 ml of the 70% substance mixed with 70%, 750 ml of the 20% so that you can make the prescription 40%, 1 liter. Did you get it? Have to double check. Add these two together. Did it add up to 1,000? Yes. It's the box. I didn't realize. As simple as putting a box helped most students. And by trying to do it ratio and proportion instead of fraction, it helps the student better. Most books will teach you this way. Once you get here, fraction. And that's when the students, I notice, mess up. So I said, what do they understand? Ratio and proportion. Let me find a way to do it. And remember, I had a professor who said there's not a single problem in pharmacy that you cannot solve using ratio and proportion. I did it. Okay, this way. Yes, Emily.
I'm just confused because 70, you like subtracted it from 40.
The first step is crisscross.
Yeah. So, and then you got 30, and then you
Parts.
use that 30 parts to connect it, and then you got X equals 750 ml. Wouldn't the 750 ml be taken out of the 70%? It would be taken out of 30?
Now remember, this is your 30%, and we calculated that it's 30 parts. You're gonna need 30 parts of it. And that 30 parts based on our calculation is 750. So on the substance, this is a reagent bottle or a substance bottle that says 30% label, you need to get 750 ml from that, and you need to get 250 ml from the bottle that says 70% to mix it. And now you made a 40%, 1,000 ml solution. Step one, what's a step one after you do the tic-tac-toe method?
Subtract.
Subtract, crisscross, okay? Absolute, but use parts. Step two, subtract again, okay? What's step three? What's step three? Either you add this line, okay? Or you add this side, okay? Or you can put the boxes now so it doesn't confuse you. You know what confuses the students the most? This 750 they put here, and this 250 they put here. That was before I started doing the box. So the box truly helped them. Because it tells them this 70%, this 10 parts pertain to 70%. And this 30 parts pertain to 30%. Are you following? Okay, now I'm going to do something on the side to show you that you can use the tic-tac-toe method for a dilution problem. Remember this? I'll get back to it, okay? If you need to see me, you can stand up. Don't say this is blocking, okay? Please stand up. Feel free to move up, sit right there. It doesn't matter to me, okay? But if you can't see, but I need the board, okay? And I want to leave this here so you understand because I want to show you that it adds up the same. Okay. Tic-tac-toe method. To write, but I wanted to prove to you that you can use the tic-tac-toe method even if it's a dilution problem. Okay. But what do I do? Test taking, just as a tip. I saw there's one concentration. It's a dilution problem. I use C1, V1 equals C2, V2. Why would I sweat it? If I saw two concentrations, I use the tic-tac-toe. Clear? Okay. But there are tests now. PMIS final exams are multiple choice. But back in the day, there are tests where in using the alligation method, Okay, but I may give you a quiz that's like that. Okay, so let's try to solve this dilution problem using the tic-tac-toe method. Okay, higher concentration.
We're doing the same problem as
I thought that.
That's why I said I'm not deleting it. No. Remember, we solved this using C1, B1 equals C2, B2. Now I'm going to prove to you that you can use tic-tac-toe with an alligation using alligation, okay, or tic-tac-toe method. You can solve dilution problem using tic-tac-toe. What's going to be at my lower concentration? Has to be a 0 because that's water. To make? Where does the to make go? Good job. Remember that. Okay? These two are exactly the same, different ways. Okay? What's my next one? 70 minus 30 is? 0 minus 30 or 30 minus 0 is? My next step. Right? I'm going to make this longer and longer. Okay? And then I'm going to start making my boxes. So that I know the 30 parts pertain to 70%, the 40 parts pertain to water, and my next will be 30 plus 40 is 70 parts. I don't want floating numbers, so I'm gonna bring this down so I know it pertains to this. Then I'm gonna make one more box. Because there are 3 components. Even if there are only 2 strands, there are 3 components to it. Are you following? Then proceed with ratio and proportion. Okay? How much total? Do I have a total? Which means, where do I put that? Where?
Well, it should be 50 milliliters on 500 milliliters.
Where should I put the 500 then?
equals 70 parts.
Very good. It is the total. Remember, the bottom is the total. This is your to make 30. So the 500 ml is the total. Remember? From this to make 500 ml. So it has to be at the bottom, not at the top. You following? Can I proceed with ratio and proportion? I can use anything. What do you want to solve first?
40.
If 70 parts, I'll erase this one now. Continuing here, ratio and proportion to help you guys out. If 70 parts is 500 ml, what do you want to solve first? It doesn't matter really.
40.
40 parts is X ml. What's my X?
40 ml.
Huh?
40 ml.
40 ml. Anybody got other answers? Who got 40 ml? I'm banking on you guys. I'm not even calculating. Let me do. 500 times 40 equals 20,000 divided by 70 is, I kind of doubted that. That's why I paused. 285.71 ml. Who's with me? Okay. Where do I plug that?
And the 40.
Over 40 parts.
There you go. This was all over the place before I started using the boxes. They're guessing. Students were guessing where to put it. So did I put it here? Where did I put it? What did you solve? So where did I put it? Here. 285.71 ml. It's telling you that you need 285.71 ml of water, right? To make the 500 ml. Now you're done. 2 ways to solve. You can do ratio and proportion. Again, 70 parts is to 500, 30 parts is to X. Or What's a simple solution to this one? 500 minus 285.17 equals 214.83 ml. Could you add and double check the 214.83 plus 285.71 is about 500. That's how you double check. There's some, it's a little bit off.
Because you put 17 instead of.
Oh, what is it? 14 point, sorry, 29. Okay. Double check 214.29 plus 285.71. Does it add up to 500? Okay, let me show you. Remember the C1V1 equals C2V2? Exactly the same. You just know that this is what you need. That's why I wouldn't sweat this if it's a dilution problem. But you can, right? Did you see that? Okay, so this tells you if I'm going to draw it, okay, this is my 70% drug label, and this is my water. So if this is my water, I have to understand that water is 0%, right? How much of the 70% do I need? 214.29 ml. Who said 83? Why did I write 80?
You subtracted 17, I believe.
Okay. And then how much water do I need? 285.71 ml. So that I can make a 30% concentration. How much? 500 ml. That means this has 214 ml, 214.29 ml of the 70%, and this is 285.71 ml of the water. That makes 30%, 500 ml solution. Did you see that? This box helped the students a lot because I was pulling my hair how to help the students. Like, why are you guys putting the numbers here, and everywhere? When I started creating the box, it started clicking and making sense. And man, this pertains to this, and this pertains to this. So let's just make a train, whatever you call it. Any questions? Okay. So personally, what I like, again, if it's a dilution problem, I saw one concentration. That means I have to add water to make it from stronger or more concentrated to a less concentrated. I use the formula C1V1 equals C2V2. If I saw two concentrations, and the problem is I have to mix the two to make the middle concentration, tic-tac-toe all the way. Okay? Because I so like tic-tac-toe. So I like to use it even on dilution. Okay. You could. I just showed you how. Anytime you see water, use 0% because it's a neutral base. Anytime you see the word pure, use 100%. Anytime you see a base, use 0%. Because it's not always water. Sometimes it's Vaseline or a petroleum jelly. It doesn't have a concentration. It's 0. Right? When we're making ointments, we use Vaseline or petroleum jelly. That's why I mentioned that. And that pertains to your weight over weight. Any questions? Now, I do have a really long practice problem, practice sheet, which you can start right now.